YouTube, Sogio here, and if you're watching this, you're almost certainly, but technically not 100% certainly, watching this on the planet Earth. And we live on this planet, we have all done that at least once, and this planet is of course not flat. Or is it? Well, it isn't flat, obviously, but it isn't the opposite. It isn't a sphere either, our planet. Of course, that can't be the case because we had things like buildings and mountains and oceans. I mean, I'm standing inside of something that makes this planet irregular. But even if you were to take those away from the surface, the planet still wouldn't be a perfect sphere. Why is this? Even if the whole planet were at sea level? Well, it's because the Earth is something called a geoid. So, with the Earth, there are some areas inside the crust, though, that will have more matter than other areas. If there are huge pockets of underground gas, natural gas, then that will of course be lower density and thus have fewer atoms and lower mass and gravitational pull than areas that are just solid rock. And this does cause a slight difference in gravitational pull across the planet. You actually be only 99% roughly of your weight in Hudson Bay compared to anywhere else on our planet, because Hudson Bay in Canada has weaker gravitational pull relative to the center of the Earth than the average for the planet. And a geoid is just a way of visually representing this. So if the planet were just an ocean that would, normally settle to become completely flat, there would be variations in its height, i.e. distance from the center of the planet, of about 200 meters. And you'd also need to do that if you wanted to build a track that went all the way around the planet, where at any point on it, if you were to place a ball, the ball would not move because it wouldn't be at an angle, it would be perpendicular to the pull of gravity. You would need to have variations in its distance from the center of the planet of about 200 meters because it's inconsistent. And the Earth is technically 12,756 kilometers wide. But that's just an average, though, and that's also at the equator, because the Earth actually boulders at the equator. It's about 40 kilometers wider at the equator than at the poles, and that is just because of centrifugal force. As the planet is spinning, the mass on it, it's not technically a force, but the mass on it wants to keep going in a straight direction, while the planet is trying to curve in the opposite direction, and so it pushes against it. It's why you feel weird when you're in a car and you suddenly go on a turn. Your body's trying to go straight, but the car's forcing you to turn left, so you go into the right-hand side of your car. That's technically happening with the Earth right now, although it's to nowhere near as much of an extent proportionally. It still causes the planet to protrude out by about 43 kilometers on the equator compared to the poles, and this is called fat Earth theory.